Dynamic motion blending for versatile motion editing. Recent years have seen remarkable advances in human motion generation across various modalities, from text and music to speech. But a critical question remains. What if we already have a motion sequence and simply want to edit it according to specific instructions? The key challenge is that traditional approaches require training on triplets, including the original motion, the editing instruction, and the target motion. Creating such high-quality triplets with accurate text descriptions is extremely expensive to obtain at scale. To tackle this challenge, we developed Motion Cut Mix, a technique that uses easily available motion databases to create more training examples without the high cost. Our method works by substituting parts of body movements from our motion database while keeping the overall meaning of the motion intact. For example, we can change the lower body movements to create many new training examples, while the upper body continues to perform actions like playing a violin. This dynamic motion blending technique allows us to greatly expand our training data without needing expensive new recordings or annotations. To get started, we created comprehensive data sets for 3 specific motion editing scenarios. First, body part replacement, where we swap one part of the body with another movement. Second, fine-grained adjustment, allowing for subtle changes to movements. And third, style transfer, where we asked trained mocap actors to recreate the original motions from the human ML 3D dataset, but in different styles. To make all this work, we developed a body part annotator that identifies exactly which parts of the body are involved in specific movements. Now let's dive into our method. We call it Motion Refit, a powerful approach for text-guided editing of any input motion. Motion Refit works in an auto-regressive manner. For each segment, it takes the original motion as input and produces an edited version based on the text instruction. Editing is performed by a diffusion model that takes 3 conditions: the previous edited motion segment, the editing instruction, and a progress indicator. This progress indicator helps the model understand where each segment fits in the overall timeline of the motion. For processing the motion data, we use a transformer encoder backbone. Body key points from the original motion are encoded as input tokens. To ensure smooth transitions between segments, we apply noise starting from the 3rd frame while keeping the first 2 frames unchanged. Additional condition terms are either added or appended as new tokens to guide the editing process. One of our key innovations ensures natural coordination between different body parts. We introduced a motion discriminator that provides classifier guidance to the diffusion model. This discriminator is trained to distinguish between natural movements and artificially composed ones. We leverage the power of Clip Model for text embedding. We invite you to try our method yourself. You can visit our live demo on Hugging Face and edit motions with your own instructions. Feel free to experiment with different editing commands and see how our system responds to your creative ideas. Here we're showing visualizations and comparisons of our Motion Refit method. We've compared our approach with 2 leading baselines in text-guided motion generation to demonstrate our editing capabilities. We've also included an ablation study showing our method without Motion Cut Mix we discussed earlier. This comparison illustrates that our data augmentation strategy is crucial for achieving high-quality results. more details, please visit our project website. Thank you for watching.